Howdy, I'm Mr. Patterson, teach academic physics and AP physics here at Seven Lakes High School. I want to speak to you briefly about what we're heading into. We just finished our conservation of momentum unit. Now we're moving to conservation of kinetic energy. We can learn all kinds of great things about energy conversions. For example, we can look at this pendulum and say, hey, if I pull this pendulum up to a certain height, how fast will it be going when it gets down to the bottom? Well, guess what? We can theorize that and calculate it, but we can also measure it and compare our theory. We can look at roller coasters, okay? Say, hey man, how in the world do they know how high this thing has to be? If I have a loop, how fast does that thing need to be going to be able to make it all the way around that loop? Well, we can actually calculate that. We'll use our little roller coaster apparatus here. Think about it, we start up at this height right here that gives us some gravitational potential energy. But as it falls and loses height, the gravitational potential energy decreases. We lose gravitational potential energy. Well, in chemistry, they told us you cannot create or destroy matter. And here we're going to tell you cannot create or destroy energy, yet we're losing potential energy. See, the great thing is we're not creating or destroying energy. We're just letting it convert to another form, particularly kinetic energy, because you have energy of motion down at the bottom here, okay? We'll also see some other types of things going on that we don't calculate, like the friction and such and the rotational motion. We have these nice little popper toys. They're always kind of fun to play with. They're very elastic, which gives us another type of potential energy. I can invert this thing and put it on the table, and it pops up in the air, and it has some elastic potential energy. So as it pops up, it moves and converts to kinetic energy, and very quickly, as it's moving upward, converts to gravitational potential energy. So there's three types of energy we're seeing right there. We see gravitational potential, we see elastic potential, and we see kinetic energy. In fact, that's the only three we have to deal with. Kind of nice. If we look at this ramp, it's a lot like our roller coaster, but there are some things that are a little different. For example, you can tell there's a lot more sound being made here, right? Well, sound is a form of energy. We're not calculating sound, so you can imagine if we do some theoretical calculations and then look at our actual values, that we could possibly be off quite a bit, right? Nice little spring here, another elastic. Anything that can stretch or compress is going to give us elastic potential energy. So I have this mass. If I hold it up here, it has a particular amount of gravitational potential energy due to its height. As soon as I let go of it, it falls. It changes height. It drops. Therefore, its gravitational potential energy decreased. That had to be converted to another form. We started gravitational, and we ended with some less gravitational and some elastic potential, right? Hey, remember our good old marble launchers? We can use these bad boys too. They got little springs in them, so we can compress a spring in there. We got some elastic potential energy. Bam! Strike that marble, we get that elastic potential energy converted into kinetic energy. And you can actually, again, calculate what the speed should be going out and measure. You get very close on that one because we don't have a lot of other things intruding. We have about three major equations and one really big concept with this. The big concept, obviously, is what you start with is what you end with. So if you can identify this is the energy we start with, this is what we end with, and you can set them equal to each other mathematically, you just solve for the unknown. It's kind of nice, okay? This is called conservation of energy. I mentioned the kinetic energy, which is our energy of motion. That's simply 1/2 mass times velocity squared. Okay, so we have some simple problems where we just solve for mass or solve for velocity, by taking square root, or solve for kinetic energy and such. But most of our problems are really going to be about, hey, we started with something like gravitational potential energy on a roller coaster, and it got converted to kinetic. So we have to take that loss of potential and make it a gain in kinetic. Okay, and our gravitational potential energy is just the mass times the height times our gravitational acceleration. So m times g is just the weight, so it's just the weight of the object times the height. Okay. And of course, the last potential energy that we deal with is our elastic potential energy. Elastic potential energy is any kind of object or item that can be stretched or compressed. We normally deal with springs. In fact, in our equation where elastic potential energy equals 1/2 kx squared, that k actually represents what they call a spring constant. We can also use something called Hooke's law to find that spring constant. We have the force that's used to compress that spring is going to be pushing back you have a restoring force when you compress a certain distance. There's going to be a relationship. And here's the great thing. There's a negative right there. What? Hate negatives. What's up? No problem. The force and the displacement are always in opposite direction, so the negative is just going to cancel out eventually. Okay? So that's just a quick preview of what we're going to be doing in terms of our energy unit. We're going to look at these different activities, and we're going to make sure that we keep one thing in mind. This is the most important thing. The energy you start with is the energy you end with. Thank you.